So a sinusoidal graph, I explained the other day, the idea is just basically a wave. Got a center line, and then it waves around, like peaks up, peaks down, peaks up, peaks down, like that. See what I mean? And that wave right there is called a sinusoidal graph. A graph that's just waving steadily up and down around the center line. So that's a sinusoidal graph. So now the truth here is, after we've spent a good amount of time studying about how we can graph sine function and graph cosine function, right? Then here's what I can see here. So now in general, when you're looking at a sinusoidal graph, and here with a wave, you've got a center line, and now go ahead and tell me in your own eyes expression, is this graph the graph of a sine function, or is the graph of cosine function? It can be either, actually, yeah. It can be either. The sine or cosine, these are all good, actually, and that's the whole point of this. So we're about getting to that idea. So now the point is, when you're looking at a graph, right, the thing that's waving up and down away from the center line here, that same graphic, you can actually see that as either as a sine function or the graph of cosine. Either way, it's going to work. See what I mean? Because so here's how I'm seeing it. See, what matters we try to chop it down to the basic units, because this graphic here is an infinite repetition, right, of the same basic units right here. So if you want to see that as a sine function, think about it. If you chop your graph down to just that window right there, that's one period, isn't it? And that's now the shape of sine. And then we're repeating it. See what I mean? Right? Same graph. Same graph. You can purposely chop it off right here. Cut it down to a window from right here. And the shape in between that is the shape of a cosine, right? And then we're repeating it. See what I mean? That's why the same sinusoidal graph right here can be explained, can be seen as a cosine function, right, or as a sine function. It all depends on how we want to see it. That's why the graph in general here is, once again, is regarded as a sinusoidal graph. Sounds good? It's waving up and down. So the skill I want to spend the whole class today, the skill I want to spend the whole lecture here is to get you guys comfortable with setting up the same wave because that's given. Right? We want to set it up, we learn that skill, set it up as a sine and as a cosine, okay? Either way we want. See what I'm saying? And the answer is going to be the same. Okay? So now I'm going to get over to this board right here. I'm going to put on the picture. So there's our picture. See? Some sinusoidal graph. Right? You got some graph up and down, waving. Right? So that's the graph. And of course, allow me to hide the actual function away because it shouldn't matter anymore. The same function here, you can see that as a sine function or you can see that as a cosine function. See what I'm saying? So what the idea now is you have the graph right there. So why don't you guys spend some time copy down? So now I already showed when we spend time learning about how to graph these things, then you already see that anytime you're looking at a sinusoidal graph here, what matters for us the most is the center line. Right? So when you're about to copy it down right now, make sure you got the center line being right on the grid. So the grid here is indicating what? We've got a center line at -1 onward. Right? And so the basic units here happens from where to where? Say you pick a point, right? Like say if you pick a point right here, then the ending of that unit is right there. That's sort of like I see one sine wave right there, right? But the period I'm seeing here is a pi, right? So those are the information that you should capture that when you draw your own copy of the graph, right? You should be able to make something close enough. See what I mean? Right? And how high does the graph pitch up and down away from the center line? The center line is -1, so it hits up to 1 and it hits down to -3. So we got an amplitude being about 2, right? So those are some of the key points that you can catch your attention, and so that you can draw the correct graph. Okay. So go ahead and make a copy of that on your note. Okay. You see that these points right here are exactly halfway between. See, like the peak right here, it's exactly halfway between the -π/6 and the -π/3, right? Which is really the graph grid right here is not showing it, but it's -π/4 again. See what I mean? Okay. And then this one right here is a positive π/4 where it hits that bottom peak with that, right? That bottom value. Okay. So right from that graph, right from that first graph right here, I want to bring up the first activity here, and I call it example 1. But the idea is from that given graph, we want to identify that as a sine function. See what I'm saying? No? We want to write down the function for the function that has that graph, right? And as a sine function. So our goal here, let me highlight that with graph. So the graph given on the picture, I want to identify that as a sine function. So sine function means what? As a general idea right here, we want to write it as a y equals, right, some sine, and with some linear expression inside, and then with some coefficient, okay, and then with some other coefficient, some other constants added after that function. And that's what it means by we want to identify our given graph that you're seeing on the picture there as a sine function. And that's the goal right there. And the wording here, think about the wording, all I'm asking is as a sine function. That means the way I'm doing it, it's just one way of writing that as a sine function. You can also come up with a different one. See what I'm saying? No? Okay? And so, but the generality is what I'm about to show right here. So that's our goal. So now, as a sine function, you got to understand, sine function got the key feature that's center line, right? It waves up and waves down in one basic unit. You got to see that a lot throughout our earlier lectures, right? The sine function, the main key feature, it waves up, starting right on the center line, right? It waves up, hits a peak, right? Waves down, cross through at halfway, right? And then swing down, hits the bottom, and then come back to right on the same line. That completes one basic unit. Are you seeing that there? Okay? Or sometimes you may want to see it like this. Some other cases, depending on your view, then you can also see that it's like this. But always starting out from the center line. You want to say, and swing away, right? From the center line, it swings away. Sound good? Okay? So now you have your choice. Actually, so I'm saying that you got your choice of doing that. The map on the picture, let me explain. You can do like this. The whole wave up and down, where's the center line? The center line is right here, right? Y equals negative 1. See what I'm saying? Huh? So right on that center line, you can pick. So how about let me show you how you pick right here. I mean, I can just pick one from here, right? Right from there, and ending right here. See what I mean? That interval from between where my point is clicking at, from minus pi over 2, minus pi over 2 to pi over 2. It looks like that completes one basic unit, right? You guys agree on that? Okay? See, right from minus pi over 2 to pi over 2, that completes one basic unit. Sounds good with that there. So with the one we chose, and I chose that one, you don't have to. You can also choose on the same graph, you can also choose start at pi over 2 and ending at 3 pi over 2 on my picture right there. See what I'm doing now? That's another exact picture of the sine graph, right? In one complete unit right there. So for now, I'm leaving the activity, so allow me to make my choice, because my choice is going from minus pi over 2 to pi over 2. So from in that window over here, how far is the period? Let me get back on that furthermore, and we're going to sketch it down. So we knew that the center line we recognize to be y equals negative 1. You guys saw it? Okay. The period was capital P equals pi. We found the periods here right from the picture. Sounds good? And then I chose that portion. I chose that basic units where it got the start at minus pi over 2. You guys follow it? Okay. And then so of course the end right here. So the end right there was happening at x equals pi over 2, right? Because negative pi over 2 plus pi is giving a pi over 2. Sounds good with that picture? Now, one thing I mentioned it earlier, but I didn't put it here yet. What's the amplitude? How high does the wave swing away? How far does it swing away? Yes, 2. There you go. The amplitude equals 2. So now we have all of that information. That's ready to put it in. Now I'm going to, you see that center line right there? Meaning at negative 1? That means the plus b right here. See how I'm explaining it? Because that last constant we added into your sine, so after the sine function is responsible for the center line. So the center line right here, you're seeing it, negative 1. That value right there now becomes, right, minus 1. You guys follow with me on that? Okay? If we go back, write in our function, right, and writing it minus 1. The shape, the picture in that basic unit right here from minus pi over 2 to pi over 2, the picture was like this, right? You guys see what I'm saying there? So does it look like a positive sign or a negative sign? Positive, right? Because the negative sign goes upside down like this. See what I'm saying? No? So with amplitude 2 that you chosen, right? And then the picture in that portion between starting the M right here is that positive sign right here. So that means what? The amplitude here is going to be just simply positive 2. Okay? Does that make sense? Because remember, the amplitude is always the absolute value of your front coefficient. Are you guys with me on that? Okay. Okay? So now we need to recognize what's inside that. But remember, it's best to do this. The inside part right here, a lot of times we factor it out in the form of some coefficient m, right, and multiply with x minus c points, right? The c here is responsible for the starting point here. See what I'm saying? Right? And then the m right here is related to the period, right? That's how we want to see it. So the information is right there. First of all, your starting point. We chose that one. So what can I put here? Minus 2, right? So your function here is 2 times sine of some number m, some coefficient m, but x minus negative pi over 2. Is everybody with me? Okay. It's always minus. The starting point is the phase shift, right? And then minus 1. Then for the last value, right here, let me do a little bit of math. The period is pi. The period is pi, but keep in mind that the period, from our understanding, the period for any trig function is always, for any of the sine or cosine function, for any sinusoidal graph, the period is always the standard 2 pi over some coefficient, the absolute value of the coefficient m, right? Remember that, then? Okay. So in this case right here, we can look at what? So the period here is already found right through the picture of being a pi, right? So pi equals 2 pi over m, and let's just assume m being positive here in our case. Enough for simplicity, right? So what do I see here? I see that solving for m, right? M multiply that here, divide both sides by the pi, and then you got 2 pi over pi, right? We're solving for m. Then the pi cancels away, m equals 2. You guys follow with me on that? Okay? And so now I'm going to come back to this. You erase out the information. Right? So instead of m, we put a 2. Have we completed our function? So I'm saying that, hey, among so many sine functions you can write, right? One of them is like this. The way how I'm seeing it, so the function we're looking at is y equals like 2 times sine of, and then 2x, this is plus, right? So 2x plus pi, you guys would be there, right? And then close parentheses, right? Minus 1. So where did all that 2x plus pi come from? Because first of all, minus negative pi over 2, making it plus pi over 2, right? The 2x multiply it, the 2 multiply it, right? And then minus 1. That's one way how you're writing a sine function that matches this graph. You guys see what I'm trying to explain? Right? And so, when you're working with this kind of stuff right here, I use decimals to verify. Right? And so now let me show you guys a little bit. I don't really advertise for decimals or anything like that, but you can also, it's a free resource, right? You can also hop onto decimals and type in your function to make sure it falls exactly with the graph. It matches exactly with the graph. I'm not even showing you guys whatever the real function behind the scene here that generates this graph. That's not even important, right? But the one we found, let's type it in. What matters is that when we finish typing it in, it should give a graph that exactly coincides with this graph here, that matches perfectly, right? That aligns perfectly with this code one. So we got 2, right, times sine of, right? We got 2x plus the pi. You guys follow it? Right now, without the minus 1, it's already pretty much the same shape, right? That new red curve that popped out right there, but it's different center line. See what I'm saying? Huh? So all we do is minus 1. See how it matches up right there? Right? So the two graphs match up right there. So now we knew that we have come up to the correct function there. See what I'm saying? Huh? Right? So that's one way of kind of doing that, right? And so back to the example. Back to the activity right here. What we found here is only a sine function. That means there can be other way of writing your sine function. See what I'm saying there? Okay. So the same problem here, I can see that as, how about, see? Again, it's y equals 2 sine up, right? And then we know that center line at 1, right? So that information is like no change in that. We we can think of some different starting points. You know what I'm saying? No? Okay. Some different starting point like that. The period is also still the same, right? Same period, same amplitude, same center line like that. Right? On the picture, you can see that we can go right here. You can pick the starting point that starts from here, right? That starts from there and ending up right there. See what I mean? Or you can also do this. You can also do this. You can pick the starting point that goes right at 0 right here, right? And ending at pi. See what I'm saying? Now, but that's making it a negative sign, right? See what I mean? Okay, let's try that. There are so many ways of writing it. See, starting right here at 0, right? And ending right here at that point right there, for pi. You guys with me now? So let's try that. Right? There are so many different ways. So the period is a pi. We start at 0, right? And we ending at pi. See what I mean? But the picture here is indeed, this time in our window over here, right around the center line, I see swinging down and swinging up. You guys following? Right? So that means what? The picture is flipped vertically upside down through the center line, so the coefficient here is going to be what? -2. Because that's responsible for flipping the wave upside down, right? And then in my next step, I can start at 0, right? So y equals -2 times sine of, I have, let's use brackets here, m times x minus 0. Sounds good. -1. Okay. And then I'm going to do the same math. We know that the period is pi, so we got pi equals to 2 pi over that coefficient in absolute value, right? But here, let's just stay, when we're working with this, it doesn't hurt to stay with m being always positive like that. So we can take away the absolute value sign. Right? And so that makes it m equals to multiply that up here, divided both sides by pi, so we got 2 pi over pi, right? The pi cancels out. Got m equals 2. So another way of writing your function, y equals -2 times sine of what? Sine of 2 to x minus 1. Same function. It gives me the exact same graph. And I'm going to really quickly test out right here with decimals. Right now I don't need this graph anymore. I can just leave it there, right? So the main graph is still here. -2, right? Sine of 2x. You see that green one right there that just popped out, right, on the screen, right? -1. It gives you the exact same graph again. See what I'm saying? That. So again, my point is there are many ways of setting up your sine function that meets the picture of our current given sinusoidal graph. Okay? See what I mean? So later on, when you get into doing your assignment is programmed in a way that it's smart enough so that as long as you get your functions down correctly, it should be able to recognize it. It doesn't matter. There are so many different ways of doing it. Okay? So, back in the same picture right there. Let's now call that example number 2. Activity number 2 right here. You guys can do that, right? So I just saw the graph. But we want to identify the given graph as the graph of a cosine function of that. Okay. So instead of sine, we want to see the wave here. We want to see the sinusoidal wave as a cosine function. So, again, now before I get back to the picture right here, I want to identify the same graph here, right? The same sinusoidal graph right here as a cosine function. So we want to write it generally as some coefficient. A, right, times our cosine function. But then in the cosine right here, we're going to write it as some m times, in parentheses, x minus c, the starting point. Right? And then plus with some constant term. So that constant term is responsible for the center line. Good. And then remind yourself that the primary picture of your cosine is that from start to the end on the center line right here, the wave goes like this. It's from a high point, it swings down, right? And then swing all the way down to the bottom and swings up. That's the ordinary picture of a cosine for one basic unit of cosine. And then in another version, in another variation, we may have the vertically flipped version like that. That goes like this. See what I mean? Okay? I peak at halfway point. So either one of those points, right? Either one of those two. So now let's recognize the information. So what matters for us is, on the picture, we're going to need to just simply chop it down, right? Chop down the picture to meet the format we want. So with our picture right here, see, I can see that I can pick a starting point right there and ending right there. That's in that window, right? It gives me my picture of the cosine. You guys following? Right. So right from that negative pi over 4 at start, right? Negative pi over 4 and completing at whatever that is right here, right? See what I mean? Right? And that gives you the picture of a cosine right around that center line. So center line is still the same at -1, right? Okay. Amplitude is still 2, right? Amplitude is still 2. So we got some of that. So sinusoidal graph, writing that as a sine or as a cosine, it should always have the same center line information and amplitude information. Okay. So now I'm going to come over there. Okay, let's put it in. So what I see is the center line is at y equals -1. The amplitude goes as high as 2, right? And then the period, it's the same with the earlier, because we're still in the same sinusoidal graphic there. So the period here is p equals pi, like that, right? So I chose the starting window here. I chose the starting picture here to be the starting of our picture of our basic units is at -pi over 4. -pi over 4. You guys see what I'm doing there? So that means the ending point here, the grid is not showing it, but it means what? Pi plus -pi over 4, right? So it's giving me a 3 pi over 4. You guys follow my calculation right there? So we got the starting point and the ending point, but the ending point here is really not that important. What matters is the starting point, and that's what matters for us. Okay? And then we chose, so in this window, our picture appears to be like just the ordinary, right, positive cosine shape there. So let's put it in. So looking at that positive cosine shape in our window, we are looking at what? Y equals, right? 2 times positive 2, right? 2 times cosine of some fancy m times x minus c, and we will fill that in later. Okay. And then -1 for the center line. You guys agree with that still? Right. And then now putting in some more information. You see this? X equals -pi over 4. Right? That's our starting point. So when we put it in, y equals 2 times cosine, and here I got m times, right? We got x minus -pi over 4, which will eventually become plus pi over 4, right? -1. Right. Are we all together still? Right. And now we're going to do a little bit of math to find out the m coefficient. So once again, right here, we know the period for our actual graph here is pi, but any of the periods is equal to the standard 2 pi divided by the coefficient in front, right? And let's assume here we're going to just say with the positive m, right? Keep things simple. And so say with m equals being a positive number, then we can just ignore the negative. I mean, the absolute value sign right here, looking at pi equals 2 pi, right, over m. So that leads to m equals 2 pi over pi, right? Canceling out a pi, that leaves me 2. So m equals 2. That's a positive number. And again, choosing m being a positive number is the same with the earlier example we've done. It's just a choice, right? There are many ways to find that. You can also choose m being negative as well. You want to say that? All right. But now m equals 2. We're ready for concluding it. So our final equation, y equals 2 cosine, right? In parentheses. And actually, let me write it in brackets first. Right? This is now 2 times, right, x plus a pi over 4. You guys follow it? Right. And then -1, right? That's how I wrote my function. And then you can multiply that 2 to each term right here. Now making it 2 is cosine of 2x plus a pi over 2, right? And then all that. -1. See what I mean? And the work I'm doing here is just the function I've got here is just one among the so many different ways of writing a cosine function, right? That gives the same exact sinusoidal graph. Yeah. And so once again, I'm going to use that mode to verify our results. So on my screen right here, okay, I'm going to write down another one here. So this is the main graph, the main sinusoidal graph. But let's type in the function that we have come up with. So as a cosine right here, I see 2 times cosine. Here I'm looking at 2x plus, right, a pi over 2, right. See how that purple one just popped out and being basically just different by the center line, right, minus 1. So that purple one falls back down, it matches, right, aligns exactly with our original function. Let's see what we're doing there. Okay. And so that's how we're doing it, right. Let's write down the third example. And the third example is indeed, actually, let's not even call that an example. This is some solid fact right here, but we do some starting out points. You see, so sine of x, but in the end, zooming far, zooming out far, or zooming in closer, you get sine of x. When you now see that as a sinusoidal graph, yes, sinusoidal graph, can we rewrite this as a cosine function? This is our sine of x right there, right? But this current graph right here is just sine of x as usual. Amplitude 1, right? And it's starting at 0, center line right on the x-axis. Nothing unusual. That's sine of x. You get that? But then we can utilize that example that we've done earlier. We can utilize that understanding we've had earlier. Now I'm going to rewrite that with that picture right there. Okay. So with the current graph, we got what, center line, right? The center line at y equals 0. You guys follow it? Okay. We got the amplitude, same exact graph, the graph for sine. I'm trying to change your point of view with that. The amplitude here is 1, right? And then we got the period being 2 pi. You guys agree with that, yeah? Okay. That means as far as the coefficient, yes, we can go 2 pi equals 2 pi over m, right? Meaning m here has to be 2 pi over 2 pi, right? Making it m equals 1. Right. So then we got the starts here at and. So I want to change your point of view that, hey, the same graph, how do I see that as a cosine? How can I see that same graph here as a cosine? We can start right here. See what I'm saying? We can start right at pi over 2, right? And ending right at pi over 2. See what I mean? Right? That completes one basic unit of an ordinary cosine with coefficient 1 and all that. See what I mean? Right. So right from there, so now I'm seeing it. We can purposely look at the same graph, but extract out, right? Chop down that portion where it starts at pi over 2, and then in the 2 pi period it's ending at 5 over 2. You guys follow me on that together? Okay, so that completes one window. Right? So the picture right in there, the picture right in that window is like this. Right? It's perfectly a cosine. That's why now think about it. We utilize that scheme we've done. The same graph. Right? We want to make it, we want to say true or false about this, but think about it. We get the graph for that, right? For that sign, and then we reconstruct it, right? We rewrite that as a cosine function. We re-identify that as a cosine function. So think about it. Amplitude 1, so it's just cosine, right? And then you got what? In parentheses, in brackets, right? Coefficient, the m here is a coefficient 1, so 1 times, right, x minus the starting point pi over 2. You guys following me on that? Right? And plus the 0, right? Center line and all that information. So now we're writing all of that. Yes, it's y equals cosine of just x minus pi over 2. You know what I'm saying? The same graph, but you can see that now as a cosine. And that's why this is now true, right? We have proven it. we have proven it graphically. Right? Yes or no? No, it's a yes, right? It was proven graphically. See what I mean? Right. So in that way, from now on, this will indeed become a new identity for us here. Sine of x, right? We will always equal to cosine of x minus pi over 2. That's just one way of seeing that. See what I mean? All right. We've got sine of x, right, equals cosine of x minus pi over 2, and we call this identity. One more identity. We have just proven it graphically by using the graph. So utilizing the skill that you guys have, let's come up with another activity. Is it true? Is it true that cosine of x, right, will equal sine of x plus pi over 2? You guys with me? Right? So why don't you verify that using the graph? I'm going to put the graph on screen right there, right? And you guys are looking at the graph and be able to count. See what I mean? Use exactly the skills you have done. Cosine of x is right here. We want to show that it's a sine, right? It's a sine of cosine of x is the same as sine of x plus pi over 2. So go ahead, look at the picture, right? You utilize that skill you have learned that you re-identify this graphically as a sine graph. And after you have proven that graphically, then we have a new identity, right? Once you can agree with that. See what I mean? So go ahead and take your time, right, for doing that. All right. I was hoping you guys got enough time on that. Do you agree or not agree? Is it true that these two are equal? Yes or no? Yes, it is true. So from now on, you have another graphically proven identity right here. Cosine of x, right, will equals to sine of x plus a pi over 2. And this is true for all x here. Another identity. It will be useful for some other applications later on. All right.